A polynomial is a single term or the sum of two or more terms containing variables with whole number exponents and their coefficients. Here are some examples. Notice how the exponents are going from largest to smallest, read from left to right. Also, it may be deceiving, but every single exponent is present, starting from the largest exponent all the way down to the exponent of 0. Some of them just have a coefficient of 0 and are omitted for simplification. This is analogous to how the variable without any exponent is actually x to the first power, but the 1 is omitted for simplification. Remember that x to the 0 power is 1, and the term attached to that is called a constant term. When we refer to a polynomial, we often refer to it by its degree. The degree of a polynomial is its highest exponent. So the degree of these three polynomials are 4, 7, and 88. If your polynomial is not in descending order, then you should probably rearrange it in order to correctly identify the degree of the polynomial. Adding and subtracting polynomials is very similar to adding and subtracting functions. The key concept here is to combine similar terms, meaning terms that have the same variable and the same exponent. Now we will be looking at how to multiply polynomials. The key here is using the distributive law, which says to take each term from the first polynomial and multiply it to each term of the second polynomial. Remember, when multiplying variables, I add their exponents together. Let's now focus on multiplying binomials, which are polynomials with two terms. The procedure that we will be using is called FOIL. It's just a fun way of describing the distributive law. FOIL is where we multiply the first terms together, then the outer terms, then the inner terms, and lastly, the last terms together. Now we just have to simplify our expression by adding terms with similar exponents. Let's try another example. When we multiply two binomials with a degree of 1, it always results in a degree 2 polynomial. more commonly known as a quadratic function. Here are some special products that you will run into. Our goal is now to go in the opposite direction. We are going to factor our quadratic into two binomials. The process is to do FOIL in reverse. Find two numbers that multiply to our constant term and add together to make our middle term's coefficient. So we need to find two numbers that add to 6 and multiply to 5. It's much easier to start with finding the multiples of 5. Here, those two numbers that we're looking for are 5 and 1. Let's try one more. We need to find two numbers that add to -6 and multiply to 8. One method I want to focus on is factoring out the leading coefficient before factoring the trinomial. If you can't factor using this method, the task becomes much more arduous, but not impossible.